All right, in this video, we're going to do the proof for theorem 8.1 to show that it is equivalent to the original definition of the sample variance. Let's buckle up and get down into it. I'm recording this video on a Saturday morning. I haven't had my coffee yet, so let's see if we can get through this while the coffee's brewing. All right, so we're going to scroll down here, get ourselves some fresh space. And we want to go ahead and do a proof of theorem 8.1. So, proof of theorem 8.1. And I won't ask you to do the proof on a quiz or an exam per se, but it is good to see that these are in fact equal. So, how do we do a proof here? We start with the original definition, and we have to show that this 1 over n minus 1 times the sum of xi minus x bar quantity squared is equivalent to what we ended up working with, theorem 8.1. So let's go ahead and start out with that original definition. 1 over n minus 1 squared by definition is that times sum from I equals 1 to n equals 1 to n xi minus x bar squared. Okay, that's our starting point, and our goal is to get to theorem 8.1. So 1 over n times n minus 1, n times the sum of the squared xi's minus the square of the sum of the xi's. All right, so let's see what we can do here. Well, first, I think a natural place to start is to FOIL out what is in our summation here. FOIL out the xi minus x bar squared. So we've got 1 over n minus 1 times the sum from I equals 1 to n. So let's expand that. That's going to be the xi squared minus 2 xi x bar plus x bar squared. All right. This is looking good already because I see a lot of the components. For example, now we have xi squared in the summation that we want. And let's use the sum and difference rule of summations here. We can take the sum over all of these pieces individually. So I've got the sum of the xi squared as I goes from 1 to n plus the sum of x bar squared. I'm just jumping from here to here. I equals 1 to n. Sum of the x bars squared. And then we have minus the sum of 2xi x bar. So I goes from 1 to n. Okay. So far so good. And let's take a look at what we have here. Now we have to kind of carefully look at these summations and see if we can simplify or work with them at all. So the sum of the xi squared, actually, I want this as is. I equals 1 to n. I want that as is because remember, if you think about where we're trying to go in our goal, that is just like this term right here. So that's a good start to leave that there. Look at the sum of the x bar squared as I goes from 1 to n. This has nothing to do with I. This has nothing to do with I. And so what's going to happen here is you're just going to add that up essentially n times. And so this second summation is just n x bar squared. N x bar squared. And then looking at the last summation here, again, 2 times xi times x bar. Again, your index is I, so 2x bar, that's essentially another constant you can factor out of the summation. We have 2x bar times the sum times the sum of the xi's as I goes from 1 to n. There we go. Looks good, looks good, looks good. And then now we can think about what this last piece, this last summation here is equal to. So I've got I from 1 to n, xi squared plus nx bar squared minus 2x bar. Now, what is the sum of all of the xi's as I goes from 1 to n? Well, recall that x bar, remember x bar is the sample mean, x bar is just the sum of our observations divided by n. And so that would mean then that n times x bar is just the sum of the observations. And so this right here, that's just this right here. This is just n times x bar. N times x bar. So 2x bar times n times x bar. Okay. Cool. So what do we have here? We have multiple x bars. This is x bar squared stuff, right? You've got 2n. So what is this right here? This is just 2n x bar squared. 2 times n times x bar squared. And we have n x bar squared minus 2n x bar squared. That leaves us with negative 1 x bar squared. Sum from 1 to n of the xi squared. N x bar squared minus 2n x bar squared means we just have minus n x bar squared. Minus n x bar squared. Okay? And so far this is looking a lot better, but now we kind of are running out of things to maybe simplify and work on. And so one thing to remember is look at where we're headed. Where we're headed, we had 1 over n times n minus 1, not just 1 over n minus 1. So let's go ahead and just force that in here. And I'm going to go ahead and multiply on top and bottom. I can't just multiply the bottom piece by n. N times n minus 1. If I do that, I also have to multiply on top by n. So I'm going to go ahead and do that. And then what are we going to have now? Now we have sum from 1 to n of the xi squared minus n x barred squared. Okay. And now let's distribute this n into our parentheses here. So we have 1 over n times n minus 1. And then we have n times the sum of the xi squared. We also have to distribute that to the nx bar squared, which is just now going to be minus n squared x bar squared. Well, here we go. This again right here, look at this. That's just nx bar quantity squared. Nx bar quantity squared. And again, what is nx bar? Nx bar is the sum of the xi's. So that is the sum of the xi's quantity squared, which is exactly what we were looking for. So we have 1 over n times n minus 1, then n times the sum as I goes from 1 to n of the xi squared minus nx bar quantity squared. That is the sum as I goes from 1 to n of the xi's quantity squared. And that is exactly theorem 8.1 that we used to get the sample variance. We are done with that. Whew, we did it. I will take a break, grab some coffee, and come back for the next video shortly. We will see you there.